Facebook with someone else. You know how to do that. And so we can populate the program that way so everybody can taste and see how good this program is. So just do that for us while we get ready to begin our program. Um, we should be good to go in a minute. I was just looking to see if I got a note from Devon. Dr. Melbourne, you want to just check on Devon for me? Yeah. Oh, he sent a text. I'm sure he sent me a text. Okay, okay, we're good. We're good. We're good. You don't have to do that, T. There are many ways he does it. Okay, everybody ready? Let's get going. Once again, we are very excited that we have another program, Perspectives. This is a program that we have every week, basically, throughout the year. We've been having a great time at it. We have been having spiritual fun. We have been educated. We have been rejuvenated. We have been revitalized as a result of this program. And we're very, very happy that you've joined us here at Redemption Praise Temple. We want to welcome each and every one of you. I hope you had a great lunch, and I know you enjoyed the Bible class. Those of you who stopped by for a moment or two, those who didn't do the Bible class, I'm sure you had something wonderful to do anyway. And so I think we have all happy people here this evening, all curious people here this evening, all excited people this evening who want to hear about the COVID-19 and the variant and variants, if you want to call it that, and what we need to do to protect ourselves and to keep being healthy. So welcome to all of you. God bless you. And now I'm going to turn this over to Mr. Plummer, who is with us. It's good to have a plumber in the house. So there you go. Over to you.
Hello, everyone. It's such a joy and pleasure to be here. Welcome, everyone who joined. Just so happy to see everyone here. Some familiar faces and some not so familiar faces, but it's really a blessing and a joy to see every one of you collaborate to educate our sons. We're here at this town hall meeting, and just for those who don't know, Collaborate to Educate Our Sons is an interfaith organization that strives to educate, develop, and nurture transformational leaders who will promote educational awareness for boys and young men. So it is embedded in the community and family culture. So if you learn more, Collaborate to Educate Our Sons, you can head to collaboratetoeducateoursons.org. So here today, we're going to be talking about COVID-19 and the Delta virus. We're going to delve a little bit more with some professionals and doctors, and we're just going to get some more information. So feel free, this is a place where you can express your questions, share your questions in the chat, whatever may be. This is a time for us to engage and learn together. So very grateful to be here, and God bless everyone who is here, and may God continue to lead us in how we're to live and how we're to grow together.
Thank you. Now we will have our prayer by Mr. Eccles.
Okay, please bow your heads for prayer. Thank you, God, for this lovely day of which we can spend so much time with you. Thank you for the amazing people who brought this meeting together. Thank you for your love and your passion. And thank you, God, for creating us, because you are such a wonderful creator. And please help all the boys and young children around the planet and mold their minds to create a new tomorrow. Please also help the adults as well, because it's not only children that need help. It is the adults too, even though sometimes we don't realize it. Adults have some of the most stressful situations in the world. And please protect us from the COVID-19 variants that are going around. Please And we know that with you, we'll survive through it, as you have done with everything. In Jesus' name I pray. Amen.
Amen.
Amen. Collaborate to Educate Our Sons is an international, non-profit, multi-faith organization that seeks to help boys and young men achieve their full potential. CEOS is built on a set of core values, including trust, character, service, and serves at both the local and the national as well as international levels. Its mission is to help youth achieve their full potential, and its vision is restoring balance to strengthen the global community. Why are we singling out boys at a time when women are just breaking the glass ceiling? Well, let me share some facts with you. In 1949, 70% of the college population was male. Today, it is around 36% for black boys and around 40% for boys generally. This is something that needs to be addressed so that there'll be parity. These are the days of COVID-19 when black and brown males are being disproportionately affected. These are days of injustice when our young black and brown boys are being made to feel that their lives are at the mercy of others who have their knees on their necks or shoot them causelessly with no consequences. Indeed, like Abner, they are dying prematurely, needlessly, causelessly, foolishly, and recklessly. This is a wrong and needs attention. Young black males need education when white high school dropouts are wealthier than black and Hispanic college graduates. And when black college graduates have a lower home ownership rate than white high school dropouts, according to 2020 information, we need organizations like this to motivate young men and to show them that they have potential that can take them and help them to soar. That is why CEOS has been doing its utmost to provide boys and young men, their parents, teachers, and mentors with the best information to survive and to thrive in these days. So we sponsor various programs that help to educate young men, help to educate their parents, their mentors, and their teachers. This evening program this afternoon is one such educational program, and we are happy to welcome in our midst Dr. Devon Taylor. Dr. Taylor is a research and drug discovery senior biomedical scientist in immunology, working in the biopharmaceutical industry. His works focus on harnessing the power of the body's immune system to combat cancers and autoimmunity. He is an expert in how the immune system works to protect and build the body's defense against infections while simultaneously regulating it from under or overacting. He is passionate about the need for minority communities gaining access to the best medicines and participation in clinical trials for new therapeutics. He has authored and co-authored several peer-reviewed scientific publications in the field of immunology. He's a graduate of the University of the West Indies, Mona, City University of New York, graduate school, with postgraduate training from the University of Pennsylvania, School of Medicine. He hails from Steertown, St. Anne, Jamaica. We are happy to have you, Dr. Taylor. We look forward, we are sitting at your feet, and we look forward to learning from you. We now turn over to you for your presentation. And let me just say here before Dr. Taylor comes, we will listen him through for his presentation, after which we will take questions. We are asking the audience to continue to remain mute and write your questions in the chat, and we will monitor them from there. Thank you. Over to you, Dr. Taylor.
Good evening, everyone. How is everybody doing? Can you guys see my screen?
Yes.
Yes, we can.
Are you seeing the full screen or are you seeing my
Full screen. Full screen.
Awesome. Great. Thanks for those kind words, and I'm looking forward to a very engaging discussion this evening with you guys. All that you guys have pointed out so far resonates with me in terms of efforts to get Black youths, in particularly males, trained and to be recognizing of their position and their role that they have to play in our society. So, I was one such youth like that growing up in a very small fishing village in Jamaica, and I'm here today, with the guidance of my teachers, my parents, my mentors, to be in a position to really engage you. So I think it is fitting, to really discuss COVID-19 and coronavirus, because I think the pandemic has thrown a curveball at our community, and we should be responsive as to how we, conduct ourselves during this pandemic in order for us to really protect our loved one, as well as, rekindle our economy. The presentation I titled here as Empowering Decision-Making Through Information, SARS-CoV-2, COVID-19, Scientific and Social Responsibility, because I think we're in an era where there's a lot of noise out there, and we need to be cognizant of the noise and distill through that to get to the real information. So this week I think we were all hit last week with the news that one of the member from our community, Colin Powell, died. And so we know that Colin Powell was fully vaccinated, and it brings to light the challenges that facing us during this pandemic, because not only that Colin had all the best health care, but Colin was predisposed to be very susceptible because of his age and his underlying conditions. And so there's a lot that's going on out there regarding how good the vaccines work. So we want to put all these into perspective. So age is actually an issue in your resistance against COVID-19, because as you age, your immune system will change, and we'll go into aspects of that discussion. This was a quite accomplished man. He had multiple myeloma, which is cancer of the blood, in which those malignant cells overtake the reservoirs of plasma cells that you would have, to fight against other infections. And so when you're multiple myeloma, immune system becomes very compromised. And that was one of the confounding effect with Colin Powell. His age is also an issue. So if you could see here that 45% of the multiple myeloma patients produce adequate response to the vaccine, but there's a larger 55% that will not. And so this population is vulnerable. He was also a Parkinson's disease survivor. So there are other, underlying conditions that we should be aware of, in this pandemic. And I mentioned age. If you're diabetic, if you have lung disease, you're immunocompromised, if you have kidney problems, if you're pregnant and you're hypertensive, all of these are conditions that you need to consider, because in light of what we're seeing in terms of breakthrough infection, where we're noticing that, we have 187 million of Americans vaccinated, and there's over 7,000 breakthrough infection that is happening. And that is actually been seen in 85% of the cases in folks above 65 years old. So the risk of dying from COVID-19 is 11 times higher in the unvaccinated cohort. And so one needs to be very careful. Not only was Colin Powell in the news about his death, but we also saw that John King from CNN have revealed that he's immunocompromised because he has multiple sclerosis. So this is another population that we need to be mindful of. And, I just like, you guys to know that approximately half of the vaccinated folks in the United States, receive, with COVID-19 breakthrough infections are immunocompromised. And that is despite this is a very small subset of the population, just about 2%, 2.7% of the population is immunocompromised, but they're making up the bulk of who we're seeing in hospitals. So we need to be careful, when we interact with members of our family, if we're not vaccinated, if we're not protected, because we could very well take this virus home and hurt the loved ones. So if you're immunocompromised, if you're older, your immune system is weak and then you become susceptible. And the right here, I list a whole slew of different conditions that make you susceptible, that drives an immunocompromised conditions. And so we need to be very, very cognizant of those among us who are not, in the best of health. So the headlines was a buzz with all this news around, vaccine skeptics are seizing that vaccine are not working. I mean, breakthrough infection kills, Colin Powell, multiple myeloma, made Colin Powell more vulnerable. That is true. And age is a factor. Why was Colin Powell remain vulnerable to COVID-19? Especially that he was fully vaccinated. And again, it's because of his age and because of his immunocompromised nature. So those are, things that we need to be cognizant of. And, there's so much that's going on out there in the news. And I'd ask, the audience, where do you get your news from? Do you get it from reputable sources, the NIH, FDA? Do you get that from the National Library of Medicine, CDC? Or you are actually going to, the social platform, Twitter, Facebook, TikTok, Instagram, YouTube, which all can be, good in of themselves, but they can be bad vehicles for for real information out there. That is, information that out there is not really credible. And so we have to trust our expert. Here we have Dr. Fauci, and we have an esteemed doctor from the University of the West Indies. And I know we have a broad audience, Dr. Carl Bruce. These are the healthcare officials that we want to rely on to provide us information. We have a very esteemed artist here, Buja Banton. Will we go to a celebrity who's an artist for our information? Or do we go to a mischievous senator, as I would call him, Ron Paul, for our information? We have to find those credible sources and get the best information. And we have to lower our risk from getting this disease. We know the vaccines are the best protection that we have right now. So we have to take these vaccines, and we'll go a lot into vaccines and the risk and safety around vaccine and the efficacy around vaccine. We need to continue to wear our masks and social distance when we can. We need to follow all these hygienes around, hand washing, and we should get tested when we can. Of course, it'd be good to also enroll in a COVID-19 alert program, just in case you've been someplace and someone had presented COVID-19 there, that you could actually check yourself out, especially if you're immunocompromised. So where are we today? So the world population is around 7.9 billion. We have so far have 242 million people infected, with over 4.9 million people dying from this disease. It's really wreaking a havoc on the planet. And we need to really get a hold of this. So what we also have seen, that vaccines are actually doing a very good job. I'm showing you here graphs of the spikes in deaths, and what you could see, the first spike that happened around in January 2021, and the second one that comes around about April, May, you could see the peak of the deaths. And if you look at that third spike that came just around July, August, you see the death rates are lower because vaccines have kicked in. So there's a decreased mortality with the impact that vaccines, brought. So, the planet is really, in a stressful situation right now with all the deaths that we're seeing, and vaccine represents, a hope. Now, there are a lot of buzz around the different variants, and we'll talk about variants some more, but the dominant variant that we're seeing right now is that Delta variant, and it's more transmittable. It's a more aggressive form of the virus. And so, those are reasons for us to really, protect ourselves and vaccinate. We're also seeing in our neck of the woods here, let's focus within the Americas, that, in the United States alone, there are more than 44 million cases, with what we're seeing in the US, over 726,000 people dying from this disease. And every 24 hours in the US, there's at least another, 1,600 deaths that's arising from COVID-19. So the disease is really a nasty disease. And you could see the trend across, Canada, Cuba, Jamaica, Trinidad, Tobago, Barbados, that, the cases are still with us and the deaths are still, unacceptable. One death is unacceptable. So we need to be, actively, trying our best really not to really be infected and to take the vaccines, because we know, the vaccination rate is low in cases. I mean, in Jamaica, it's only 11%. We're up to around 40% in Trinidad and Barbados. And in the US, we're only at 56%, despite the fact that we have the most vaccines on the planet. Canada is at 72%. So, it's a social responsibility for us to really get vaccinated so we can protect the population. And the data is also showing, if we look at, vaccine, against hospitalization, and look at vaccine against death. So if we look in 100,000 folks, what we do see here is that if you are 80 and older, you'll find out that around 54 folks who are unvaccinated will succumb to COVID-19 versus, 11 people if you are vaccinated. And that's if you're in the 80 plus zone. So, what the data is actually showing is that less vaccinated are dying compared to unvaccinated. And that is something that we need to pay close attention to. If you're between 65 and 79, only, 2 in every 100,000 person will die, compared to 35 if you're unvaccinated. And so the trend here is very clear. Vaccination is protecting the most vulnerable of our population. If we look at, hospitalizations, what we do see is that there's a decrease in the number of COVID-19 patients in hospital, with vaccination. So this is the first or second spike that we saw just about, in February. Look how high, the number of individuals in hospitals are, and that number comes down in October 21 because, the vaccination strategy is actually working. But what we do see is hospitalization among ages 0 to 4 is 10 times increase. And because there's no vaccine available for these kids, the FDA have now authorized the Pfizer BioNTech vaccine, for the younger cohorts, 5 to 12 years old. So those guys, kids will be able to, really be vaccinated and be protected. So, I pulled this case out so we could really look at this case. And this is vaccinated versus vaccinated. And this is a case study in Indiana. And we're looking at just the cases of infection, hospitalizations, and death. And the blue is the unvaccinated. And we see in all cases, in terms of infection, hospitalization, and deaths, those are higher in the unvaccinated compared to the vaccinated. So the data is driving the conversation that vaccine do protects. You could look broader trend across the entire United States and look at the number of COVID-19 cases per 100,000 folks versus the number of deaths. And you do see the unvaccinated are these dotted lines here. There's a higher caseload among the unvaccinated compared to the vaccinated. And that's the same when you look at death. That translates right into death, where we see that there's a higher mortality within the unvaccinated compared to the vaccinated. So the data is driving the conversation that, you're 10 times more likely to be infected. You're 10 times more likely to die from COVID-19 if you are not protected through vaccine. So, the symptoms of this disease, I think we're all very familiar with these symptoms, from fevers to chill to cough, presentations such as diarrhea, fatigue, and headache. These are all of these things. But I want a case to point out here is that, you may go out for dinner, places are opening back up, and you get exposed. You got home, you're feeling happy. You visit your mom or your dad who are immunocompromised, and then you go to work, 3 days later, 4 days later, and you start feeling a little bit sick, and then you get tested and you realize that you're positive. By this time, you've already transferred that disease to your older, parent or grandparent, and so you have to be mindful as you are, moving out there that you're young and you got robust immune system, but your older relative may not. And so we need to be cognizant and we need to be responsible during these times. And so the timeline here, I will jump this slide because we kind of went through that just now. So I want to go into a little bit of depth now about this severe acute respiratory syndrome, abbreviated SARS, CoV-2, the virus that caused the coronavirus disease of 2019, COVID-19, and talk a little bit about this bug. So, the coronavirus family has been around for quite a while. I mean, we have seen in 2003, 2004, when the original strain came about, that was known to infect civets and jump into raccoons and dogs, and then mutated so it could occupy human. We also known about the MERS-CoV-2. That was another member of the coronavirus family that was also found in camels, and that mutated and was able to infect human. And then we're now in 2019, when we are seeing the SARS-CoV-2. The host of that one is still unknown, but it has mutated and it has made its way into humans. So the coronavirus has been around since 2003, and the scientific community has been studying this virus since then. So it was actually, in a good position to really kind of take that learning to apply it to develop therapeutics to really combat COVID-19. So I want to put some stuff into context for us right here. Okay, looking at a couple of infectious disease, measles, smallpox, polio, mumps, and look at these guys and see how contagious were they. Now, the measles is a highly contagious disease. I mean, one person who is infected with measles will pass it on to around, 12 to 18 folks. If you are positive for, say, the mumps, you'll give that to 4 to 7 folks. And if you are for coronavirus, you will give that to at least 1 to 3 people. Now, the Delta variant have changed that number, and we'll talk about that a little bit. But if we look in entirety at the entire, coronavirus disease that we experience on this planet, we can see that, the coronavirus that we're seeing now, COVID-19, is responsible for more infection. I mean, there are over, as I mentioned, 242 million people infected with this bug, and over 5 million deaths. If you compare that to the SARS in 2003, there were only, infection of 8,000 people, 744 died. The thing is that it had a higher mortality rate of 10%, and MERS had a higher mortality rate of 34%. Luckily, these were not made their way into a pandemic and were controlled. So, for all the biology folks on the forum, we won't belabor this, just to point out that the virus contains very different parts of it, and all these different components serve the role of, allowing the virus to replicate, to occupy its host, and to survive. And the scientific community have really targeted the spike protein, because this is the that red triangular shaped object that you see sticking out of the membrane. That is the component that is responsible for the viral infection. So it's like a lock and key, situation that we have going on here, where that spike protein is able to bind on what we call an ACE2 receptor on our lung cells or our intestinal cell, and then through that mechanism trigger an entry into your cell to then start the replication process and then destroying your cells. So, you know, a closer look here just shows your cell membrane with the ACE2 receptor there and the virus locking onto that receptor. And so this spike protein is very important because the vaccines were made to actually bind to this spike protein and block it from binding to your ACE2 receptor. So then you won't gain, the virus won't gain entry into your body. So here's a virus teeing up itself to approach your cell in your lung. And so once it does that, it's going to enter into your body. So we could see a cartoon here showing that the viral binds onto your ACE2, it gets encapsulated, it enters inside your body, and then the replication process begins. It hijacks the machinery of your cells, and so it does a number. Once it replicates, it's killed that cells, and then you start losing those cells in your lungs. And that what leads to the pathology. What leads to that pathology is that these alveoli that are very important in gaseous exchange. As you know, oxygen comes in, carbon dioxide comes out. You know, it's a very efficient structure that is within your lung. And so when the virus infects, it actually destroys these little alveoli. And then that leads to a fluid build up inside your lungs. You develop what we call COVID pneumonia. It's almost like you're drowning in your own body fluid right here. And that's a result of so much damages that are taking place. So your organ does not function anymore. So you undergo what we call acute respiratory distress syndrome. And then you can experience lung failure and you will die. I mean, other things that are happening inside there is that bacterial infection increases, so you develop sepsis. Not only is the condition localized to your lung, but I mean, you develop other issues. You could have acute hepatitis, you have gastrointestinal complication, you could develop a stroke, develop heart failure, and we also now know that the virus will also travel to your brain and leads to lesions on your brain. So a lot of folks who have recovered would develop what we call, you know, cognitive impairment. And in kids will develop this multi-system inflammatory syndrome called MIS-C. So no one is actually spared from COVID. So this is really a nasty disease. It also leaves long-term effect. All right, people who recovered, as we are showing on the right here, just several of the organ systems that this bug will actually target. And so when you recover, your body have to repair all these systems. So you still, you know, have shortness of breath. You will still have a cough. You will be fatigued. Your loss of taste and smell will linger on. You'll have some issue concentrating, nausea, diarrhea. And some people have acute kidney injury. And so, you know, you may survive, but you may develop just long-term complication from the disease. So, I mean, you know, we talked a little bit earlier about underlying condition, but the more of these underlying conditions that you have, which are just medical condition, you may be asthmatic, you may have high blood pressure, you may be hypertensive, you may be obese, you may be diabetic, you know, you may have cancer or any kind of neurological problem. These are underlying conditions that exacerbate your COVID. And, you know, I mean, you guys were talking earlier about race and ethnicity and poverty. These are also risk. And that's because, you know, many of our household, we don't have 5-6 rooms in our home. You know, we work multiple jobs, so we can't really quarantine, isolate very well from our family members. So these kind of conditions will actually make our COVID worse. And the data have also pointed out very clearly that age is a problem. Age is a co-founding underlying problem in many diseases. Older folks get more influenza, more cancer, more Alzheimer's, more cardiovascular disease. And so it is no surprise that older folks also have more COVID-19 mortality. And that's because as you age, your immune system gradually, decrease. It becomes less effective at countering pathogen through a condition that we call, a mechanism that we call senescence. Your cells are dying, they don't repair, they don't turn over very, very fast. So, I mean, we could dive a little bit more into, why this is happening, but we know that, your thymus, which is very important in making your T cells, you lose that with age. I mean, so your naive and your memory cells that are supposed to be protecting you are decreased. Your B cell numbers that makes the antibody, those guys are decreased as well. As you get older, you have more inflammation, so you run the risk of more tissue damages. So just aging of your immune system, the aging of your body, really predisposes you. Your stem cell niches that are required to keep your body regenerating, those capacity are reduced. Your bone marrow has less of these protective cells inside here, and so less makes it into the periphery. So it is a biological phenomena that age does on our bodies, and so as a result, you're more susceptible to COVID-19. Now, if you are actually younger, of course, old as well, there are three parts of your immune system that will allow you to fight against any infection. You have that innate part of your immune system. You got the adaptive part that constitute your humoral and your cellular immunity. So, I mean, these are all kicking in once you get infected. So that innate cells are your neutrophils and your NK cells that will come in and bind to the bug, lyse those viral particles and remove them from your system. Your body will start making, antibodies against the virus through a particular cells that we call a B cell that differentiates into what we call a plasma cell, and that churns out a lot of these antibodies. If you're immunocompromised, you do not do this process very well. You're slow at it, you make less of it, and so you're susceptible. The T cells, these are your natural killer cells. So these will target a cell that is containing a virus. And it knows this because when the virus infects a cells, it kind of pops up a little flag on the surface of that cells, and the T cell can sense that flag, go in for the kill, and lyse those cells. So your immune system is really functioning. It will really kick in, and it works very well. And once you have seen this virus and your immune system works, then you develop what we call memory. And that memory should last a lifetime. And for those of us who really have a good, robust immune system, we are naturally protected if we become infected with the coronavirus. Parts of your innate immune system is also, new learning, points to what we call this trained immunity within the innate part. Normally does not make memory, but this can protect you for up to a year. I will jump over the details of this. This just outlines all the sophisticated mechanism that is happening at the cell-mediated and humoral level. But I'll point out that once you get exposed to coronavirus, that viral load increases in your body, and your adaptive immune system kicks in. And once that kicks in, then that viral load, drops down. You make a lot of IgM antibodies, a lot of IgG antibodies, and those are what is responsible for that decline in the viral load. And so at the end of a 21-day period, you'll be making good, robust IgG antibodies. And that's what the vaccine is doing, though. It's artificially giving you part of the coronavirus for you to build up your immunity, and that should protect you. Now, there are many therapeutics out there that the scientific community is working on, from antiviral to convalescent plasma to neutralizing antibody to anti-inflammatory, and the vaccine. And we'll go a little in depth with the vaccine. But, there are medicines out there that, can help us. We know remdesivir and Merck molecule that would just come out. We'll talk about that in a second. But in the early days of the pandemic, when there was nothing there, we had to use convalescent plasma. And that was harnessing plasma from folks who recovered from COVID-19, and through what we call a passive immunity process, transfer that into sick folks, and that gives them a fighting chance. Subsequently, Regeneron, Eli Lilly, and AstraZeneca, they have all made versions of their of these monoclonal antibody, and they're available. So we have the anti-inflammatories such as the corticosteroids, dexamethasone, the anti-IL-6. All of these serves to help to really tone down the inflammatory response that the virus drives in your body. and give you a fighting chance. There are some emerging therapeutics. There's a lot been said about ivermectin. It has proven that this drug does not work very well. It was shown in laboratory testing that it reduces viral load after 7 days, but in real world evidence, it's not really holding up that ivermectin is an effective treatment for COVID-19, and so it's not a go-to medication. There are a couple of meds here that I put on X beside that have been tested in clinical trial and have shown not to really be effective. But this Merck MK4882, the molnupiravir, it is shown to be actually effective. And so this is the one that is receiving FDA EUA status, and it has shown when compared to placebo, and if you increase the dose of this medicine, you see if you test for viral infectivity by doing what we call a PCR reaction to look for the presence of the virus, you do see as you increase the dose of this drug, over time, the virus disappears. And so this medicine, I think, is going to be good in the arsenal that doctors will have to fight against the disease. Convalescent plasma I just spoke about earlier is where we harvest blood from a patient who recovered, and we transfer that into someone who is recovering. And in the developing world, this practice is still being done because some of these medicines are very expensive, and convalescent plasma are shown to be work once you go in early or you give that to immunocompromised individuals. These medicines can be very expensive for the developing world. So we know that Regeneron, Eli Lilly, and AstraZeneca have made versions of these, passive immunity medicine, and they're actually available commercially, but they are very expensive for the developing world. You'll have to pay somewhere between $1,500 to $6,000 per treatment, which we know is not, readily available for our brothers and sisters in the developing world, but they are effective. So let's talk about vaccines. So, there's many concerns around the side effects and uncertainty about the effectiveness of vaccines. And, a survey that was done last year, showed that a lot of people were concerned about side effects. A lot of people want to know more how well they work. 31% of the people who were interviewed, did not think they need them. And some people, worry about the cost. So we'll actually give you guys as much details as we can. And first, we want to define a vaccine as a medicine that normally trains the body's immune system so it can fight against a disease that it comes in contact with. So these vaccines are normally designed to prevent rather than to treat a disease once you catch it. And vaccines are our best defense about many diseases. But what we have learned that coronavirus mutation have occurred and caused breakthrough infection, and that happened because the original strain of the virus changed. So the vaccines are not working as a preventative, but they're working as an agent to reduce the severity of the disease and to prevent hospitalization. And we'll show you some data around that. We are accustomed to taking many vaccines on this planet. Just look at the list of vaccines that we have here. You guys have taken MMR for measles, mumps, and rubella. You have taken hepatitis vaccine, meningococcal. You've taken pneumonia vaccine. You take a flu shot every year, and polio vaccines. So vaccines are not something new. They're actually responsible for, prevented so many communicable disease on the planet. So, the advent that we're in around vaccine skepticism, vaccine hesitancy is not new, but I think it's just overblown because we have a history of taking vaccine on this planet. And the risk to vaccines are not new. Polio vaccine carried risk, measles, mumps, rubella carries risk, and the smallpox vaccine also carries risk. And we have actually taken nonetheless. So I want to speak about this new age of vaccines. Pfizer mRNA, you've heard that a lot. The Moderna, the AstraZeneca, which is a viral vector similar to the Johnson & Johnson. And we also have the Chinese version of Sinovac and Sinopharm, which are weakened or inactivated vaccines, virus. And then Novavax, which is making a viral protein. And so we are in a technological era right now of, new genomic sciences. So mRNA, is that messenger. It's part of your nucleic acids, and that is an armless piece of the coronavirus that was cloned out and used to actually make this vaccine. And I'll speak a little bit more about mRNA because there's a lot of a buzz around there that, it's going to get inside your nucleus and it's going to change you. None such thing is going to happen. The mRNA is actually exported outside your nucleus, inside your cytoplasm, to really go through a process called translation to make protein. So it's actually, very safe. So these vaccines are made very quickly, and because the technology allows you to kind of manufacture this very fast. And then we have the viral vectors in which we are actually, taking the DNA from the virus, but only towards a spike protein, and we're trapping that inside a viral vector that has been removed from, all its pathological effects are removed, and they contain only that spike protein component, and that is then used for vaccination strategy. And then the Chinese have made the traditional approach where they have used weakened form of the coronavirus to actually, develop their vaccine. And Novavax have made a protein fragment from the coronavirus and have used that. So let's talk a little bit about what mRNA is. We know that all our genetic material is contained in what we call that DNA. For that genetic information to move from a cell to cell when our cells divide or when we procreate, that DNA has to be unwound and a process called transcription occur. And that mRNA strand is like that message, contain all the message for our genome. And that's not different from the coronavirus as well. It makes an mRNA strand, and we could actually clone out only the spike component from that mRNA and use only that part. So we can see the DNA representing that R drive on your computer, and we can see that mRNA is like that software, okay? And that software is what we now use to now make the the document that we want, if you will. You use a software to write your essay. That is kind of like a simple way to look at it. So it contains all the instruction is contained in that software as you type on your screen. And then that moves inside your cytoplasm and translated into a protein that is now the body detects as foreign, and the body uses that to raise an immune response. And just for transparency, this is what that little nanoparticle you guys are hearing about. It's just pretty much a drop of fat, that is trapping that mRNA strand inside. And then that is being used now for vaccination. So it's no magical science. This has been going on for a long time in the scientific community. We've been studying all these nanoparticles as how to deliver different things across a cell membrane. And a cell membrane looks like these is bipolar lipids that, you guys have seen this all the while. When the little drop of oil goes into water, it does not blend with the water. It actually forms a little bubble, and that whatever inside that bubble is actually protected. And that same kind of technology is used. And, how long does the spike protein actually stays in your cell? It does not stay long. That range can be from 30 minutes to 24 hours. And as I mentioned, we are not using the entire virus, only the spike protein mRNA is used, not the entire virus is used. So you can rest assured that, you're not going to get sick from this vaccine by picking up COVID-19 because only a part of it's been used. And how this actually works is that the lipid nanoparticle fuses with your cell membrane to deliver the mRNA, which is then made into a protein for a process called translation inside your cytoplasm. And then that now educates the body to start making different antibodies against that spike protein only. So once you get infected, it then will be able to recognize that spike protein on the surface of a coronavirus and then kill the cells or remove it from the body. There's full transparency as to what these vaccine contains. Okay, I mean, a whole slew here. I mean, if I had the time, we'll go through them, but nothing is in here that is going to hurt you. I mean, some of these things are actually in, some of the products that we use. This big fancy name here is just the lipid membrane. And then we have potassium chloride, we have sodium chloride, we have sucrose, which is just a sugar. And these are in just really nano quantity amount. And so, the pharmaceutical companies have really clearly laid out what is inside these vaccines. So to release the fear that you think, you've been, loaded up with a chip, you've been loaded up with something to hurt you. Nothing is going to hurt you. These are all different chemicals that are safe to consume. And so the safety of the vaccine has been around for a while. For a while, the scientific community have been testing mRNA vaccine. They have tested them against influenza, against Zika virus, rabies, or cytomegalovirus have all been tried. So the technology has been perfected over several years. And even most recently, as in 2017, a German biotech company, and this is published stuff that you could Google up in the Lancet, and they have shown that they've tested a mRNA vaccine against rabies, and they showed that this mRNA vaccine was well tolerated. Moderna, prior to the COVID-19 pandemic, also tested 2 mRNA vaccine for influenza, and those studies have been published also. That was done in Germany, and again in 2019 also, they also test these guys against CMV, and Zika was also tested. So mRNA, you may have not heard about it, but the biology was being developed. The Johnson & Johnson works just slightly differently. Instead of mRNA, it uses a strand of DNA that encodes only the viral protein, and that viral vector is able to bind to your cell, get encapsulated. The difference here is that the J&J and the AstraZeneca and the Sputnik from the Russian, really sends their genetic material right into the nucleus, but it's only encoding the spike protein, and that cannot be incorporated in your nucleus. It makes the mRNA, and then it spits out the mRNA in your cytoplasm, and then you make that spike protein, which then goes on, to educate the immune system, to make antibody and to generate a T cell response, which will protect you. So the T cell response will kill the bug, the antibody will neutralize. All right, and again, the contents here are published. They tell you how much particle you're getting. You're getting like over 2.5 times 10 to the 8, that's over 200 million particles of that vaccines, and the J&J is giving you over 15 billion particles, and all the contents are there. So it's a pretty transparent process. Now, most of these vaccines, you get 2 doses. You get a primary dose on that day 0, and then for Pfizer, 21 days later. For Moderna, it's 30 days later, and for AstraZeneca, it's 4 to 8 weeks later. You get that secondary shot. Your immune response goes through the roof, and then you elicit very effective immunity. Now, technological advancements have come a long way. All right, look at these phones that we were using back in the days, and look what we're using right now. Here's a cameraman who would have to be filming a scene off the side of a helicopter. 2019, we're using all these drones. So, we cannot expect that science was going to stay in the past. Science is advanced. So the speed at which we are making, or developing a drug is actually condensing. So it would take you somewhere, around 10 years to make a medicine, right? But with the advance of technology and what the government put in place, it reduced that time frame down to like 1 year. And I kind of like want to briefly explain how that was done. All right. So remember, we know about coronavirus from 2003. So it's 2019. The scientific community understood a lot about this bug then. It's not a radically different bug. It's just more infectious. It's used those same spike protein. They're just more heavily mutated. So what the FDA did was allow pharmaceutical company to run the phase 1 trial while they were also running the phase 2 trial, while they were also running the phase 3 trial. So all of these trials that normally spans out over a period of 8 years are condensed within a period of months, because you were able to run the phase 1, phase 2, and phase 3 concurrently. And at the same time, you were actually making the drug in the factory. So if the clinical trial was successful, the medicine would be very available immediately. And then this BLA process, which biological license application, is normally a lot of paperwork done with the FDA. And so what the FDA has done is to say, clear your table. Nobody works on anything, only coronavirus approval. And so they were able to condense that 10 or 15 years down into 10 to 1.5 year, 10 months to 1.5 years. So that's how the rationale was there. And then of course, the government just piped a lot of funding inside. I mean, as I said, China identified a sequence very early, passed on that to the rest of the world. Over $12 billion was kind of piped into developing the vaccine. Moderna got $2.5 billion. GSK got $2 billion. Pfizer got $2 billion. So a lot of money was thrown at the problem. And so the problem, was solved. All right. So this is kind of like some data to show you how the Pfizer vaccine is really performing. Here's the Pfizer vaccine against the placebo. This is just looking at the incidence of infection. If you got the placebo, you're going to get infected. You got the Pfizer shot, you are not infected. The same was said for the AstraZeneca, 2 doses of that vaccine. The blue here is the placebo, and the red here is the vaccinated. You could see the very much differences between those who are received the vaccine compared to the placebo. And so there's a lot of vaccines out there, and the efficacy of these vaccines are good against symptomatic infection or severe infection. So the Pfizer, we see it's around 95% protection, excuse me. Moderna, Sputnik, Novavax, Sinovac, AZ, they are all 50% or above, which was the threshold that the WHO put forward as being acceptable to prevent symptomatic infection and to prevent severe COVID-19. Now, there's also a conversation out there, if you're naturally infected or vaccine, which is better? This is a risk that you really do not want to take. Okay, so a study in Israel was done and shown that if you were naturally infected, you develop good immune responses, and that could shield you against the Delta variant. Right? While that may be true, I would not want to run the risk to be infected. So you should really think about being vaccinated. It will protect you. I mean, more than a third of the folks who were naturally infected did not raise, high quality antibodies to protect them from reinfection. And so, like vaccinated individuals, immunity can also wane in folks who are naturally infected. Vaccine offer, some added benefits here. The effectiveness it lasts for a longer time. We know that weaning is happening, and that's why the boosters are on board right now. It's a more standardized and more predictable response that you will get once you're vaccinated. And what is also shown that some folks undergo what we call long COVID. They suffer from symptoms of COVID for a very long time. And what they're seeing is that once they get vaccinated, that there's a marked improvement in your response or in your recovery once you get vaccinated. So these are not meant to be, opposing effect. They're meant to be actually supporting. If you are naturally, or got natural immunity to infection, you're still encouraged to take the vaccine. You just have a better protection. And if you're not, you should not really wait around or allow yourself to be naturally infected, because you don't know how you will respond. So what we do see though is that there are breakthrough infection happening. Okay, and so if you look at illness, hospitalization, and death, and you're comparing the unvaccinated in blue compared to the vaccinated in green, you do see that vaccinated individuals are actually also getting ill, but at a lower rate. All right, only 20% of that population will actually feel some impact of the COVID-19 infection. And hospitalization, it's only 0.1% of that population will end up in the hospital. And furthermore, 0.04 will die. So the vaccines are actually preventing death and preventing hospitalization. And this is true when you look at a study also that was done in the UK, that you do see, unvaccinated, a higher rate of death. And as, one get vaccinated, you can see the trending down. So the data is not lying. Vaccination is offering some protection and good protection. So it's, if you're not vaccinated, it's something that you should consider. Now, what really brought this into full line around breakthrough infection was an incident that happened in Massachusetts, where a lot of vaccinated folks, were participating in some fun events there. And there was a spike in infection that occurred around, in July, around July the 19th. And the healthcare officials were very concerned. So they, in collaboration with CDC, they tested, most of these folks. And what they found out that some of the fully vaccinated folks were actually infected. And in fact, when they did a PCR reaction that we're seeing on the right here, and what we're looking at here is an indication of viral titer, that the viral titer was similar in the unvaccinated and the vaccinated folks. And so this raised an alarm bell to say that, wow, then we are seeing a reduction in the vaccine's efficacy, and we need to be concerned about that. But this was around the time when the coronavirus had mutated. And so what we were seeing is that a different kid was on the block. Now remember, the vaccines were made originally against that original strain, which is the Wuhan strain that came out of China. And that, was in 2019, and we are in 2021. So the virus undergo some mutation. And why do viruses undergo mutations? Viruses have a poor proofreading mechanism, so they make a lot of errors in their replication process. And these errors, the virus, really will take advantage of it. All right. So some of these, variants happen because they give the virus some replication fitness, allow them to survive better in different environments. They make them more effective at damaging the host, right? So they're more virulent. They evolve traits that allow them to evolve that, make them better adapting to to hosts. And also, the virus wants to live, so it may want to jump from one species to another, and it wants to escape the impact of the immune system and resist those drugs that were given to really kill that virus. So all of these conditions will push a virus, to artificially or to, to naturally evolve. And so we end up with this Delta variant, and that Delta variant was proven to be more, good at transmitting itself and causing more havoc. And so what we're seeing are breakthrough infection because we now have a more virulent version of the coronavirus that is floating around. So that is part of, one of the reasons that you're seeing vaccinated individuals, who are experiencing COVID-19 infection. So what the community has also said is that, we want to explore mix and matching of the coronavirus vaccines. And so if you, look at all the players that are in the North American market here, Pfizer, Moderna, Johnson & Johnson, AstraZeneca. AstraZeneca is available in Canada and the Caribbean. There was a study that was done, where they mix and match these different vaccines and to see if we do that, will we get better protection from these, new variants that are coming about? And the data says yes. So if you look here at that first figure that's on the left, you're looking at total spike IgG and IgA titers. If you are only taking 2 doses of the AstraZeneca, you see where your number is, right around, averaging around, 200 units. If you mix that with 1 dose of AstraZeneca and another dose of Pfizer, look where you are. You are more than 3-fold higher in terms of your titer, so that should offer you more protection. When you look at just viral neutralization assay, this is done in the lab. You take the serum from vaccinated patients, and then you kind of, infect a cell with virus, and you throw this antibody on board, and you kind of observe how well it's been protected. You do again see, if you get your 2 doses of AstraZeneca and then you get a boost, you see that your titer, your neutralizing capacity is high, around 540. But if you get your both doses and then you hit with a Pfizer, you go above that several folds higher. And that's the same case across all these slide sets. So the CDC now has approved a process where you can mix and match. If you got your 2 versions of Pfizer, you can boost with a Moderna, a Johnson & Johnson, or an AZ. And likewise, if you got your both doses of Moderna, you could then, go in with a booster shot with these guys. Or if you only got 1 version of Moderna, you could take a second of Johnson & Johnson. So the mix and matching is proven to give us a lot of protection. All right. So the Delta variant, as I said, is another version that have gained better skills, because where the Delta spike protein is engaging our ACE2 receptor, there are many mutations that happen in that spike protein. And these mutations have caused this virus to gain new skills, better at actually infecting. And so you'll hear a number thrown out there about the R0 value, which is just the number of people someone who is infected can infect. And what we're seeing is that if you're infected with the Delta variant, you can infect up to 7 people. All right. So previously, if you had the first version of, let's say, the Alpha or the Wuhan, you were only infecting 3 people. You double that because this virus, has acquired, some new skills. It is more aggressive, more transmittability, can do that, evade the immune system a little bit better. And so we are hearing now about the Delta Plus variant, which is a version of Delta. It is a version of Delta that carries a mutation that is similar to that was seen in the South African variant that was very, very, elusive to vaccines and to therapeutics, more contagious, binds to the lungs better, and will evade your immune system. And we don't want that to take hold in our population, because, as vaccine effectiveness reduces over time because of different variants, your immune system won't protect you as well. And the data has been clear to show you over a 3-month window how the Pfizer vaccine was moving from 95% efficacious down to 78%. And AstraZeneca was also tailing downward too. This is again showing you Pfizer at 88% down to 74%, and so forth. And this is because, for one, the virus is changing. 2, you may not be building as more effective immune response, because your B cells may not be actually churning out as much antibodies, but your memory T cells should still be there. And that data set is not out as yet. But what we do know is that against the original virus, that efficacy is very good, but against the different variants, that effectiveness is reducing, hence the need for boosters. So who gets these boosters? If you're 65 years and older, if you have an underlying condition, if you're in a field that puts you in a high-risk zone, you're a healthcare worker, you may be working in a restaurant dealing with lots of customers. If you're in a long care home, nursing home, retirement homes, you are high risk and you should get a booster, because what that will do is increases your antibody titer and offer you more protection. There's a timing for when you get it for Moderna, 6 months after your second dose. Johnson & Johnson, you could go in as early as 2 months. And then Pfizer, again, is 6 months. And of course, couple that with your mix and matching. So as I get closer towards the end, the winter months are coming. Virus just love the winter months. And so we need to really, be thinking careful as to if we're going to social distance or we're going to go for vaccine. We need to be mindful that this is a time when we're all indoors as well. There's more spreading going on, more spread happen, more variant that comes about. I want to briefly talk about side effects here from some of these vaccines. You do get some tiredness. You may get swelling at the injection site. You may develop a fever or chills. These are mild side effects. There are some other side effects that can arise from anaphylactic shocks, and those are reported by the CDC. They have only seen 2 to 5, per every million person in the United States. So these will occur when, the vaccine will trigger some difficulty breathing because your throat will swell up, your heartbeat increases, you get dizzy and you weak. These do happen, but in a very small cohort, 2 to 5 people per every million. There were some blood clot issues that were seen with AstraZeneca vaccine and with J&J vaccine. The report from the CDC, have shown that, more than 15 million people have received the J&J vaccine. This was only seen in 47. So therefore the benefit outweighs the risk. And you should, if you got one of these vaccine, you should just be, be very, cautious. If you see some symptoms coming on that you normally don't feel, then you need to consult your healthcare official. But if we put blood clot into risk, into perspective, blood clot is not something new. Whereas 5 in every 1 million person would develop one from vaccine. If we look at oral contraceptive, it's like 27 persons in every 1 million. If you look at the use of heparin that is given as a blood thinner in the hospital, 2,000 to 3,000 persons who receive heparin will actually develop a blood clot. So it was in the news for a while. It was overblown, but it's a real risk, and we should be vigilant about it. And some of the symptoms that are associated with these thrombotic events will include just severe persistent headache, blurred vision, shortness of breath. So if any of these are uncommon, if you take the J&J or the AstraZeneca, you should alert your healthcare officials. Now, one of the things that we do see with mRNA vaccines are myocarditis, inflammation in the heart muscles, or pericarditis, inflammation around the lining of the heart. And what the reporting system in the US have seen as of October 13 is that they received over 1,638 reports of myocarditis or pericarditis among kids who are 30 age or younger. Now remember, there's millions of people got this vaccine, so the rate is still very, very low. The cause is, we don't know why the vaccines are doing this, but we need to be also vigilant. It's more prevalent in the adolescents, young boys, age 16 or older. And the community is studying that very closely. It normally resolves itself, does not lead to a lot of deaths. But as I said, if you take this vaccine and you're noticing any of these kind of, heart palpitation issues coming on, you need to. My 14-year-old and my 17-year-old are both vaccinated with Pfizer, and they did very well. They had massive fevers, but they were fine. And in just for transparency, also vaccine-related deaths. Now, over 408 million folks in the United States have gotten a dose of the vaccine. The death that has been reported is around 8,878, 0.0022%. So, if you look at the deaths that occur from COVID-19 in the world, it's over 4.9 million folks. So therefore, the rate is very low. So the benefits outweigh the risk. But we need to be cognizant that there are some risk associated. But you make your decisions, but be reminded that this disease is also hurting our population. So I want to jump to variants very quickly, because we went through this a little bit earlier. But I want to mention that what's happening here is that we're seeing the R naught value, the number of people one person can infect changes with mutation in the virus. And that is something that we should not be comfortable with, because the longer the virus stays on board is the more mutation is going to happen. Now, as I mentioned, when the virus is replicated, when it unwinds its strand, it has a mechanism, what we call a proofreading mechanism. It's like when you write an essay in Microsoft Word, and then you run a spell check on that. And that software is very effective at catching those errors and making those correction. I mean, some of those errors will get by. I mean, many of us knows when we write in our own mother tongues. I mean, certainly when I write Jamaicans, I mean, Microsoft does not really knows it, so it flags the whole thing as error. So, some of these errors will not be proofread, and these error will translate into a new strain of a virus that gains better skills. All right, so I could jump by that one. There's another other part of the virus, spike protein, that the virus used for protection. And, I mean, the spike protein is what we call also heavily glycosylated. There's a lot of sugar residues that are tagged on to the virus. And these serve the purpose to kind of block out antibody from binding to it and neutralize it and remove the viral particle from out the system. So not only that mutations are happening, but also the glycosylation pattern that is on the spike protein is changing. And that gives the virus some level of protection too. You think that bugger wasn't smart, right? Nature is pretty smart. I mean, it does wonders. That's why these bugs, they are more ancient than us. They're older than us. And, I mean, they're going to figure some way to outsmart us. So we got to really get ahead of the game. This is just, pointing out that, there will be escape, but, you will have the virus. Antibodies will be detecting different parts of the spike protein. So, I mean, when you get vaccinated with any one of these different vaccines, they will mount immune response, not to one epitopes, but many different parts of the virus. And so, it offers you some level of protection. So, we don't need to go into renaming the variants, only to say that the original strain started in China, made its way into Europe, then it mutates, and then, of course, all hell break loose. The CDC have a system of classifying these bugs of variants of interest, that, we think are associated with changes. And there's been several slew of these: epsilon, zeta, eta. You will hear them call out lambda, mu. They're all different variants. Some of them did not really make the cut, didn't survive, but they're happening nonetheless. Then we have the variants of concerns that, show that they have increased transmittability. The alpha, the beta, the gamma, the delta, those are all, variants of concern. They increase hospitalization, lead to more death, and the efficacy of vaccine were reduced. This is just showing you different areas on the spike protein that are mutating to give you a slew of different subvariants, even within a variant family. That is why we now have Delta Plus. All right. If you ever hear about a variant of high consequence, this is the time to run and go hide, because that means there's a major failure. All right. Clear evidence that prevention measures and the medical countermeasures are severely reduced. All right. Failure of the diagnostic, just significant reduction in vaccine efficacy, significant reduction in the EUA authorized vaccine. And we are at, day zero again. Nothing like this have shown its face right now, and we're happy for that. We need to keep this bug down the road. I spoke about Delta already, so I won't go back into Delta. But just want to point it out here that 2 doses of your AZ, 2 doses of your Pfizer, 2 doses of your Moderna, gives you some good protection against, the Delta variant that, started in India. And this is one of the reasons why the community moved away from the Indian variant, because there was a lot of hate crime that were arising based on where they say virus was originated: South African strain, Chinese, Indian. And so the community had to move away from those names and give them these Greek alphabet names. So, One that we're here about is the mu. I'm going to jump by mu. It's right now kind of quiet, doesn't hear a lot about it. And I want to talk about, how do we get ahead? All right, this is data that just showing you mutational frequency against fully vaccinated rate. And what we do see is that the lower the vaccination rate is the higher the mutations that we're seeing. And the higher the vaccination rate is the lower the mutations. So what we're seeing is that vaccination reduces virus presence in system, in countries, and that reduces mutation frequency. Reduce mutation frequency reduces all these strains that's going to pop up and keep this pandemic just going on and on. Our immunocompromised communities are suffering. Our kids can't go to school in several parts of the world. Economic fallout is happening. So we need therapeutics. Vaccine is one such of them that can help us get ahead of this curve. And we need to get to herd immunity. Now, when this whole pandemic started out, we were taught that we needed only 70% of the population vaccinated, so the virus will run out of space. So this is just showing you no herd immunity. Every red guy can infect a blue guy, versus when you have more herd immunity, every red guy is jumping to another guy who already had the bug or is protected. It runs out of space, and then the bug dies out of the population. So the emergence of new variants, can only happen when we are not at that herd immunity. And so with Delta on board, we need to get to at least 83, 90% of our population vaccinated to really get to herd immunity. And the longer we wait, we may get to a variant such as mu, taking over, and then we need everyone to be, and we'll have a problem. I am going to stop right here and, take your questions. I have a couple more slides, but these are all around myths that we can actually address during the question and answer session. So, thank you for your time, and hopefully we can get into, a robust discussion.
Okay. Thank you, sir. I would like to ask that we remember to send our questions in the chat so that we will be able to get them to ask. Let me begin with this one, just about where you ended. Is it safe to say that the more unvaccinated persons we have, the more likelihood there is of the development of new strains, new variants?
Yes, that is very correct. And that is because, the virus is going to figure out ways in which it should survive. Now, your immune system will make an assault on this virus, and this virus will try to adapt, to change to your immune system. And so by going through those adaptation, we call that immunological pressure. It will mutate. Also, naturally, the virus is infecting your cells and it's replicating, and its proofreading mechanism to really weed out the errors, it's not very robust. So those errors are going to happen and a new strain will arise. And if that strain, is much better at, than the first strain at, infecting other cells, it is going to become the dominant strain. So we do, run the risk, as the longer the pandemic hang around, the more unvaccinated folks, less protected they are, is that we're going to see, more mutations arising, and we could have, greater problems.
Okay, thanks for that. Now, let me approach that one from another perspective, which is this. We tend in the West to be very individualistic. It's about me, it's about I. And so I think that the vaccine is not good, not safe for me. So I am deciding that I am not taking it, not thinking about the fact that I am not an isolated individual. Because since I am interacting with other people, it is possible not only for me to get it from people I'm interacting with, but for me to give it to people that I'm interacting with, so that my approach to this whole thing should not be from the individualistic perspective, but more so I should remember the fact that I'm in a community.
That is very correct. And the point here is about the vulnerable amongst us, the immunocompromised among us. As I said, 2.7% of the US population, makes up the immunocompromised pool. But, more than 50% of who in hospitals are from the immunocompromised pool. So we have to think about those. We got to think about our, parents who are diabetic, hypertensive, our cousins, our sisters who may be lupus patients or Sjogren's syndrome patients, from, HIV. It's a community approach. We got to think about the kids who cannot go to school because, of this, conditions. Folks who have been laid off, lost their jobs. So this is actually a social responsibility of our community to really protect the larger community so that, we could get on with our lives. It is the right thing to do. So you're spot on that, we cannot think about this from our perspective alone that, okay, I am healthy, I have a good immune system, and so I will be okay. That I is something that is going to hurt the larger population. So we need to move away from that and embrace this social construct in which we are part of this society. Someone breaks into my house, I don't take on that person. I call 911 and I receive help. My house is burning down. I don't put my garden hose on and put it out by myself. I call the fire department. So, it takes the entire village to realize that we are in this together. And so we need to embrace whatever treatment modality that is shown to be safe to help protect the larger good of the population.
Okay, good. Here's one question from the chat. Why did so many blacks die from COVID? Does vitamin D make a difference for this population? If so, why so little discussion?
So I'll say COVID-19 does not discriminate as to what your race is, what your ethnicity is, what your religion is, what your gender is. It does not discriminate against that. What, however, do we saw early in the pandemic and still happening is that because of poverty, all right, and you guys could see this in many instances of our lives, right? Less, black kids in college, less we receive, the socioeconomic status is, lower in the society. All of these things brought on conditions in our household where more of us are living in closer quarters than in more affluent families. So if someone developed coronavirus, goes home, they are in a 2-bedroom and there are 5 of them, everyone in the house is going to get it. All right. So, socioeconomic condition. If you're in an affluent family, you have 5 rooms in your house, you got coronavirus, you go isolate in one room, you don't spread that to the entire family. All right. Now, also, incidence of hypertension and diabetes tend to be also higher in our population. And these, for some reason, predisposes you to worse COVID. And so with higher incidence of some of these underlying conditions, all right, and they may not be managed properly because we're not doing our, 3-month checkups for our hypertensive or, taking our medication, doing our annual checks, which is also a consequence of socioeconomic conditions. Then we are more susceptible. Obesity. We do not eat right. So you find, large subset of our communities also obese. COVID-19 does not really do well in the obese population. So we carry a lot of underlying condition that predisposes us to worse disease. And so, yes, race, ethnicity, because of the socioeconomic construct, predisposes us to more incidence of the disease. But biologically, it's not that we are more susceptible to it. It's because of socioeconomic construct, which we need to remove. It affects us in our education system. in our criminal justice system, in all of the lives of African American and African people in the diaspora. We find ourselves in aspects of these positions, and disease manifestation is one of them. Now, where vitamin D is concerned, it has shown that vitamin D can improve your immunological response, but it is not, vitamin D is not a treatment option for COVID-19. You can take it as a supplement. It has been given in an hospital setting in high doses, but it just helps to improve your immune system, but it's not a replacement for any of the treatment modalities that we have out there.
Thank you. May I ask the audience again, if you're not, please mute. We have asked everybody to mute. We are hearing what's happening around you, and it's disturbing our ability to hear what the speaker is saying. So thank you for muting. Oh, here's another question. Thank you for that answer. There was a brief mention regarding natural immunity. Has the science considered vaccination response regarding those who have developed a high immune response, high antibody levels months after infection? Would vaccination not then put the immune, system in overdrive? Or have studies not been done to assess these variables?
Okay, so natural immunity from coming naturally in contact with the virus versus vaccination, right? For, a large, subset of the population across the planet, you will raise a good response to SARS-CoV-2, and you may survive, all right? And months later, you'll do antibody titers. I have friends who were exposed and are recovered, and I've looked at their titers, and their titer, is high. Not only just antibody, but their adaptive immune response in form of T-cell responses will also increase. Most of the literature is not really, you don't see that a lot out there, but the work has been done, has shown that, folks have raised just good T-cell responses, and T-cells are responsible for surveillance in any infected cells that come in contact that are infected with SARS-CoV-2 and eliminate that. So you will be protected from natural immunity. However, not every individual who are infected naturally will mount a very good titer. Some folks will just be asymptomatic. They didn't even know that they had COVID, all right? So maybe their innate immune system did a very good job, and so they did not mount good antibody response. Those folks, should really be vaccinated. Now, when you are vaccinated, they normally ask you to wait some 90 days later before you're vaccinated. And that is to allow, your immune system to kind of, get back into what we call a contraction phase before we hit you again with another dose. This is almost like a booster, if you will. If you, recover from COVID-19 and you decide to be vaccinated, it's almost like you're getting a booster. The capacity of the human body to actually homeostatically control your titer is phenomenal. So you're not really going to flare and enter into what would call a cytokine storm if you follow the guidance of your healthcare professional as to, when you get vaccinated after you recovered. You should make sure that you're virus free first, because you don't want to really be vaccinated while you have virus on board. That is not something that is recommended or not good. Once that virus is off board, then you can be vaccinated. You will not be pushing your body into any harmful zone, because every day that you walk out of your house, you are encountering a pathogen, and your immune system is working at it. The immune system detect a threat, neutralize that threat, stay alert for a while, and then goes to sleep. And if that you encounter that threat again, the immune system comes alive again. That is what we call immunological memory. It lives with you. It's like tetanus. It's like you get the MMR vaccine. Those plasma cells, those T cells are sleeping. If you travel to another country and you encounter the measles, the mumps and rubella, that memory kicks back in and everything wakes back up. So you can be vaccinated after you have recovered successfully. Your system will maintain homeostasis. You won't be harmed by it. And natural immunity versus vaccination, I mean, the jury is not out completely on that. My personal views would be someone who recovered from natural immunity should evaluate their antibody titer. Go to your healthcare officials. There are a lot of tests out there. These are called ELISA tests, antibody tests. Will tell you how high that titer is, and then you will know how well you are protected. And nothing is wrong from getting the vaccine. You're just going to make more titer and more protection for you.
Okay, here's one. Let me throw this one in. I heard of an individual who had COVID-19 5 or 6 times and survived. This person is now an anti-vaxxer. Now, care to comment on the number of times this person has had it, whether or not your studied opinion would be that person having it 6 times needs vaccination rather than thinking that my body is strong enough to overcome it and being an anti-vaxxer?
Now, that's an anomaly to get the bug 5 or 6 times. You can be reinfected. So the strain that was dominant in Brazil was actually known to infect, multiple times. So folks were, were reinfected. I'm jumping to my slide around the different variants, because this may, sound like someone who is actually experiencing several different variants. Now, I don't know, maybe this person is a world traveler and saw, the alpha, saw the mu, saw the lambda, saw the kappa, saw the lambda, saw the theta, saw many of these. It would be highly unlikely that the person is being infected with the same strain every time. That means their immune system would not be doing a very good job. Now, it is possible that this person have what we call long COVID. Now, the virus stays in them for a very long time. So every time they get tested, they will show that they're carrying the bug. And so they never really kick the infection from the first time. This can go on for 7, 8 months. I mean, an individual like that needs to really consult with your healthcare profession so that they determine, if there is any virus on board. My recommendation is, once there is no virus on board, this person should be vaccinated. I think it will prevent them from, becoming infected again, because what I suspect is also happening with every infection, you are getting damages to your organs, because the virus doesn't just go in there and sits. It goes in there, it infects a cell. It infects a cell, it kills that cell. Cells makes up tissue, so you're damaging tissues. Then tissue repairs. When tissue repairs, normally there's a process called fibrosis that occurs, all right? The healing process that is not perfect. And when that happens, then you are having internal complications that are, gonna show itself in, a couple number of years. So that person, I would recommend to get a PCR test. Once that person, is deemed to be no longer infected, I would recommend they get vaccine, because this repeated infection is not very good. And they may also be the source of variants.
Okay, good. Now I have 2 questions surrounding ivermectin. The first one says, a doctor in Jamaica delivering a presentation to our staff last week and advised that he uses ivermectin to treat his COVID-19 patients, but it's the ivermectin for treating humans and not animals. Are you aware of this? That there are 2 types of ivermectin? Just checking, as I have never heard anyone mention this before. The other one is kind of similar. It says You're saying ivermectin is not effective, yet we are hearing that there are other countries that are using it effectively.
Okay. So so yes, there are two. The first question, yes, there are two different. It's the same drug, different doses. So you know, it's normally used for parasitic infections. All right. But ivermectin is a very old medicine. It's been around for a very long time, and it is a good drug. I mean, in fact, the developers who developed ivermectin won the Nobel Prize for the drug. It's used, you know, to clear a lot of infections in Africa. I mean, you know, what the committee has seen, an in vitro assay was done, and it was shown, and I'm showing it the data right here, that with increases doses of ivermectin over a 7-day window, you would kill virus. So that was kind of like one of the precipitating kind of driver to enter into trials around ivermectin. So a lot of clinical trials have been done and are ongoing to really determine if ivermectin is effective. I think what many of these trials are showing, all right, when they look at the placebo arm, is that the efficacy of ivermectin is not greater than the placebo effect. And so it is not recommended as to your go-to treatment for COVID-19. There are better medicines out there for it. So the animal versions of ivermectin is a really high dose that is not recommended for humans. Drugs are normally given by body weight. And so you're not as heavy as a horse, or you're not heavy, you know, as many of these other animals out there. So the dose would have to be high. The other thing that the literature have pointed to increase this doses that is seen in a dish, you would have to get to such a high dose in the lung to effectively drop the viral load so much to really lead to a biological significant outcome. So the dose needs to be really, really high. And so, I mean, that is the precaution that the community wants folks to be reminded, that then you could start having off-target effect. It can start, you know, harming other systems in the body because the doses are too high. So that's the key around ivermectin. I think there's a large trial that is ongoing now in the UK to really kind of really carefully, you know, check this thing out if it really pans up. But it's really, I would say, not a go-to medicine for ivermectin. So that was, you know, your first question. The second one was for ivermectin was, remind me of the second one.
The second one was saying that you were saying that it's not effective, it's not recommended, yet some doctors, some people are saying that other countries are using it effectively. What should we believe?
Yeah, so Brazil and India, it's been in the media, it's touting out there that it has. See, the thing I'd say, I mean, and I have had a couple of conversation on the airways in Jamaica. I would say to folks, if you are a clinical person in Jamaica and you think ivermectin is working in your patient cohort, you should, you know, engage in a clinical trial. You have the drug there. I think you need to have a control arm and a treated arm. And you need to do a carefully conducted study. And then let the community know this, if this thing is working as you said it's working. Because as I preface this conversation, it's a social and scientific responsibility for us to actually bring forward the knowledge that we know. So, I mean, as a scientist, I always stay open. What I'm basing my decision off here is what the scientific literature is saying. Is that the dose of ivermectin you have to get to really, you know, drive a response is going to be too high to deliver that in what we think is safe. But if you think you are going in early in your population when the viral load is very low in your patient, so it's like convalescent plasma. If you treat a person with convalescent plasma within the first 5 or 3 days, the thing works like a charm because you do not have a lot of virus on board. But in the developing world, a lot of folks do not report their COVID-19 very early because the testing is also not effective in the countries. So if we had a very robust surveillance system where folks were being tested and knowing that they were positive very early, and ivermectin can work at say 400 mg per kg because you're intervening in the first 3 days, then maybe it's doing something, but we need to do the clinical trial. We need to structure the study so we could get that data out there, and that is our scientific imperative. And I think that's why the FDA, the European Medical Association are saying you can use this medicine, but only in the context of a clinical trial. And once this clinical trial has proven to be effective, share the data with us. It will be peer reviewed and a decision can be made. But right now, you can't just treat anyone with ivermectin. I mean, you can, but it's not recommended that you do so.
Okay, now we're doing well. Here's another one. You mentioned that to make the vaccine, part of the virus is used. Could you comment more about that, on that?
Yes. So as I mentioned here, the virus is made up of several components. All right. You got spike protein, membrane protein, nuclear capsid protein. You got envelope protein. But what we do know is that the spike protein is that part of the virus that engages the human cell. All right. So if you are able to block that spike protein, then you prevent that engagement with the human cell. And so that is why the scientific community went after the spike protein to choose that as a target. So in development of drugs, we always want to identify what is this mechanism of action. And we are very clear about COVID-19 because, I mean SARS-CoV-2, because we know SARS-CoV-1 and we know MERS uses a spike protein to gain entry into the cell. So what the community has done is now to basically only clone the gene for the spike protein. Now, as I mentioned, the mRNA technology will take the message only for the spike because we know that's the part of the virus we need to block. And that is what is being used now in the medicine to now make that antibodies to the spike. So once someone is immunized with that mRNA, it translates only into the spike protein, part of that spike protein. Your body sees that now as a foreign object, and then it raises an immune response to that. And so you becomes protected. So I hope that will help you. I'm going to jump to one more of my cartoons here because I want you to really get that part here. Okay, that here is the coronavirus. Here is that blue-green area that was presenting the spike. We only clone out that part of the coronavirus. Then we put that into a nanoparticle, deliver that to you as a vaccine. Your system is now able to make antibodies to that spike because all your body is producing inside the cell are parts of the spike protein. And so you gain your protection there.
Thank you, sir. I'm going to break my rule. I think the First Lady has her hand up. I'll give the First Lady a chance to ask her question.
Thank you, Pastor. It's just that I can't write too much right now. I'm so sorry.
Okay, that's good.
But thank you so much for allowing me. Thank you very much, Dr. Taylor. Profound. There are 4 things that I want to ask. And this is basically for a friend of mine who has become a serious anti-vaxxer. And the reason why is because her aunt, who was a brilliant woman, brilliant mathematician as a matter of fact, no illness or anything that she knows of, and she was in her 60s or 70s, died within a week or 2 after being fully vaccinated. So she is totally against it. Now, according to the CDC data that the coronary heart disease folks stated that children are 107 times more likely to die from the shot than from COVID itself. That is one of them. What would I say to her? That's one. Number two, fully vaccinated countries have the highest number of new COVID cases. And this was cited in the European Journal of Epidemiology. And they said that they have to be looking at a reassessing about this whole vaccine thing. If you're going to be fully vaccinated and you're going to still be having the highest cases. Sweden, Denmark, and parts of Europe there have halted the Moderna vaccine for younger age groups because of the same thing that you described about the myocarditis. And there's also this a sort of a Guillain-Barré syndrome, sort of a non-specific thing going on that they're not so sure about. So Sweden, people under age 30, they have stopped it, they're halted. And Denmark, I think it's under 18, they're halted for the time being. And the last one is the skepticism because of who we know Big Pharma is. That they don't want ivermectin, which is considerably cheaper medication and would be more readily available to the masses. And of course, they wouldn't want that to be the medication of choice because it's all about greed. So those are the areas. I'm sorry to be bombarding with so many because I think you addressed most of them already, but I just want to give her clean answers from you. Thank you so much. And fantastic. You are a brilliant man.
All right. Well, thanks for, sharing your friend's, story. And I'm, saddened to hear the passing of her aunt. Condolences to her family. And, COVID has touched, several of us. And so, it is, as I said, social and scientific imperative that we really get ahead of this thing. Now, it would be interesting to understand her aunt case. She was 60 to 70 years old. Now, we know that group of individuals, their immunity wanes off. Why does the immunity wane off? Because, age do a number on us, all right? It does a number on us. Once we get age, you could, sense it within yourself. You can no longer run a mile in under 10 minutes, all right? You can't lift up as much everything. You can't swim as far. There's several things that you can't do anymore because of just your physical limitation with age. Your immune system is no different. It also weans off as you get older because your marrow, your bones make less marrow. In the bone marrow, there's a lot of stem cells that are in there that requires the repopulation of your B cells repertoire. It falls off. Your thymus, which makes all your mature T cells, disappears. And so you're not making new T cells anymore. So your diversity of your immune response decreases with age. And that is why naturally older folks will have more fevers, have more cold, they'll succumb to more infection. Now, she said her aunt may have never really got any of these things, and coronavirus is a different beast. It goes in, it pops those cells within your lung. It also, loves the lining of the gut, and it may have done so much damage that her body could not, repair itself. Now, I would say, it would have been because there's a lot of limitations in terms of doing autopsies on COVID-19 deaths because of the, the infections, are very, dangerous for a mortician. But it would have been really good to understand the autopsy from her, as to what they saw, if there were any vaccine adverse event, because there are vaccine adverse events in the form of, blood clots that we have seen. It wasn't an anaphylactic shock because that comes on very early, but it could have been, some blood related events. Now, all of those are unknowns. And so in science, we like to follow the knowns. And so all that data set would be good. Now, when you mentioned about that, kids are 107 or so times higher to die from getting the shot from the disease. That data set is, I'm not familiar with the actual number, but I'm familiar that, some countries have altered the Moderna, the mRNA vaccine, the Pfizer vaccine for the younger populations. Yes, because they do very well. Again, their immune system is young and robust. There may be something also with the ACE2 receptors that are in younger population. The virus does not really bind to it robustly, but it's probably their immune system is very good at protecting them. So the mortality in the younger population is actually very low. So because the risk to these younger folks are lower, then these countries will make those decisions as not to, because the myocarditis and the pericarditis that are being observed, are seen as higher risk in these countries. So, every country will make their own, requirements around these things. So I would be, okay with a country examining their incidences in their country and making those calls in the younger population. We know they can be carriers of it. And so, it was the concern while schools were closed and while schools are still closed in many parts of the world, is that a young person can pick the bug up and take it home to their older grandparents and parents, and then they can't do very well. So we have to be mindful of that social responsibility. But if we're putting the kids at risk, here's the data set from the CDCs that shows, of all the cases, there were about 1,600 reported cases of myocarditis and pericarditis in the younger population. And they normally, recover very well. But I'm aware that, some European countries have altered these mRNA vaccine. Why this is happening, we don't know. All right, that's an unknown and it's an active area of investigation. Now, you also mentioned fully vaccinated, cases here, that Denmark is one of the countries that halts there. You mentioned about Guillain-Barré syndrome. Guillain-Barré is not something that is specific for, COVID. Many vaccines out there, some subset of the population will experience this neurological phenomena. And so, it is a side effect. The frequency of it in COVID is not higher than for any other vaccine. So, if that's what you're going to use to say, I'm not taking this vaccine, then you should look at how many people who got infected with COVID-19 and did not make it. It's 4.9 million people. So the benefit outweighs the risk. So those are personal decisions that you have to weigh as to what your risk level are, and if you have any history of allergic reaction, then you want to discuss that with your healthcare provider.
Okay, all right.
There's someone needs to mute their phone, please. Are there?
Pastor Clark, could you mute your phone for me, please?
Just one more thing, Doc. With all that being said and all the uncertainties, should the vaccination be mandated?
All right, I'll get to vaccine mandate before when I answer the big pharma question. I should remind you that companies like AstraZeneca have made it a priority not to make any money from the vaccines. So they sell the vaccine at peanuts to recoup the manufacturing cost to make this vaccine. So they're not making any profit. They've also shared their technology with the Serum Institute of India to make this vaccine for the rest of the developing world. Pfizer, Moderna, Sputnik, all these other, countries that are making them, are charging for them. But, these are reduced costs. And I'm not standing here, defending pharma for the price of their medicine. Drug discovery is a very expensive process, and people get involved in it to make money, just as though people get involved in business to make money. So the social responsibility that they have to play is that countries like the United States, Canada, and European Union are buying millions of vaccines and are giving away to developing countries that cannot afford it. So this social responsibility has been met by wealthy countries, and companies such as AstraZeneca are giving away theirs for peanuts. So that is something to be mindful of. You mentioned also about fully vaccinated countries as higher rates of coronavirus. I don't think that is true. All right. What you may also see is that Delta comes on board and increases the rate of positivity because it's a new variant. It's different. And so you will see in Israel that was highly vaccinated that they had a spike, and then they went in with a booster shot and they controlled the spike. So if the virus changes, the medicine is not going to work as effectively. We started out with the Wuhan strain, and that Wuhan strain mutated. Now we're at Delta. So the efficacy of the vaccine changes over time. And so you will see these spikes. And that's why these boosters are being recommended for the immunocompromised, for the high-risk individuals, to increase the protections around it. So that relationship between vaccination and spike is not because vaccine is driving more spike, but it has to do with viral mutation within the population that is, having breakthrough infection. And so boosters should help with that. Now, your last question was around, remind me, you had so many questions, but that's okay. What was your last question?
Yeah, you can go ahead. I think she was satisfied.
Oh, she was. All right, good.
All right.
Her question was about the mandate.
I think.
Oh, the mandate. Yes, the mandate. I'm not a big fan of mandates. All right. This is what I'm a big fan of. I'm a big fan of engagement, conversation. All right. That's what I'm a big fan of. I'm a big fan of, your local doctor, all right, who understand this disease. For your kids who, study biology in college, for your kids who are in graduate schools, for the whole scientific community in the biological science to be part of the conversations now, to really talk to our parents, talk to our community, talk to our friends. And that's what I do. I try to give as much information about the biology of the disease, the clinical pathology of the disease, so you could understand it, making oneself accessible to really have these discourse around, other than having politicians comes in the forefront and using aspects of this for campaign benefits, for building their numbers in the poll. So they push these things for, and folks, as mandate. I'm not a big fan of mandate. I know it's hurting the workforce. I know some folks stay away. There's shortage of lots of things in the supply chain because folks are not at their jobs. And so companies are feeling that burn in terms of their cash flow, in terms of, their productivity, meeting their demands. And so they think the only way to do this is to mandate that you take this and return to work. I'm not a big fan of it. I think, we are in an era where information can be disseminated if we have the right person telling the story. And this is why I'm saying, where do you get your information from? If you're getting your information from Twitter, Instagram, YouTube, Facebook, and it's not coming from a reputable, trusted source, such as the CMO of a hospital system, from the FDA, from the CDC, from your local doctor, then, you're going to be confused. So you got to close up those tablets. You got to contact your healthcare profession. You got to have a sober discussion. So like that woman that was mentioned earlier that says she will never take this because what? She is burnt. Okay, she's traumatized by the passing of her aunt who was otherwise very healthy. Okay, then I would say to her, I feel your pain. Okay, but we need to understand this. Part of your social responsibility is to protect yourself and others around you. And, I mean, let us know what you are uncomfortable with. All these things that your friend just asked, if we have not answered them effectively, then we can talk to you on a one-on-one basis for you to understand that this disease is real, it's dangerous, it's killing lots of our population. And at the same time, mandate can further isolate individuals. It can. So companies are instituting measures in that they're saying, okay, you got to be tested and tested on your own dime. I think those things are also unfair. Now, members in the community says, you got enough information out there. There is enough information for you to make up your mind, but you can't make up your mind. We are creatures of our own, thinking. We need time to process. We need time to understand these things. But I just want you to understand the social impact, okay, the economic impact, especially on the kids. I have personal information around my own kid who could not engage on a virtual platform and did not do very well, struggled to learn over the computer. And he's back in the classroom now and he's doing much better. I mean, losing many years of their social interaction. We're social creatures. Kids in kindergarten needs to be out there among their peers. And this pandemic lingers on in the developing world. It's a problem. You can see oxygen shortage from India to Jamaica to parts of the United States, in Brazil, in Africa, because of so much ventilator support that is needed. The disease is real. Okay, the needs that it will break hospital system in poor economies is real. And a lot of folks are falling by the wayside, and it's the poorest of us. So we need the social intervention. Again, not a fan of mandate, but we need to have the conversation to know that we need to return to normalcy. And vaccine gives us a fighting chance to do so.
Okay, here are a few more questions. Thanks. That was very good. We learned a lot. This is, why do some people have strong reactions to the vaccine? And a follow-up is, why are you likely to have a reaction to a second vaccine when you didn't have it to the first?
Okay. All right. So, I mean, I guess you're saying strong reaction, such an adverse reaction, right, to the vaccine. I mean, the adverse reaction to vaccine is not one that is fully, understood. All right. But, some folks will have a very, very active immune system that really get ticked and triggered easily. It's like, folks who suffer from seasonal allergies, which is an immune response. Eosinophils and neutrophils and basophils are very, very, alert to different kind of pathogens or pollens, and it goes off. Your immune system goes off, and then it leads to inflammation in the airway, and you don't breathe as very well, and you're stuffy. My eldest son actually have that kind of a response. You're just have a overly active immune system. So that may be one of the things that really, when that spike protein is produced in your body, it's a lot of it that's produced because they do give you a big, dose. And so it may be that just drives your immune system into overdrive. And so you have that response. The second one, dose, what we call a secondary immune response. It's geared towards pushing the immune system to, another level. And we need to do that because we need to generate what we call memory. So the second shot, because you already have what we call antigen experience on board, you've seen this thing before, and then this thing is trying to come at you again. You're like, no way. So you give it a big push, all you got. So your immune system just goes into an overdrive. And so you get a fever, you get a stronger headache, you feel lethargic because, your body system is telling you to just kind of lie down and relax. I mean, my second shot, I had a fever and I had lethargy for like half a day. And I was fine after that. It's actually, once you can sustain it, it's actually not a bad thing, because what it means is that you're making really good memory. So when you have a temperature, it's like I would tell folks, do not take an anti-inflammatory. Some folks will take a aspirin, a Benzic, a Panadol, or something before they get a vaccine. So they're putting on an anti-inflammatory on board before they get their vaccine. They're actually dumbing down their immune response. And so the level at which you would get protection is somewhat reduced. I would not encourage that. My youngest had a fever for an entire day. We had to cool him down. We keep good eyes on him, and he was fine. So the second shot is just because you have gotten the first, your body has been experienced, as I said, antigen experience, immune system is heightened, and it sees this guy comes on board again as an enemy of your system, and so it goes into overdrive, try to knock it down, and in such you're mounting good immune responsive, lots of B cells being made, lots of T cells being made, lots of memory cells being made, and you should have a robust response. Check it. Just go bleed yourself, not yourself, go to your doctor, get an antibody test, and I can guarantee you have a lot of antibody on boards for the folks who really spike a temperature, and maybe have a swollen lymph node under the armpit. Those are just showing you that you had good T cell responses.
Okay, there's another question. Is coronavirus known to cause pancreatic issues or issues with the pancreas?
Not that I know of, but there are several organ systems that the coronavirus. So you see, any cell in your body that express the ACE2 receptor, the virus can bind onto it. So if your islets cells express ACE receptor, and actually, I think I have a picture in here, then it will be able to bind the coronavirus. And if it binds it, then it's going to kill those cells. And of course, that's regulating your glucose system. So they're showing you that long-term infection from and they're pointing to diabetes there. So it seems that your pancreatic cells do express ACE2 receptor, so they would be susceptible to coronavirus. The vaccine is not going to go after any of your organ systems, because as I said, the vaccine goes after the spike protein. Spike protein is not some protein that you express in your body. That's a foreign protein. We do not have that in us, period. That's a viral particle, that's a viral protein. So, getting the vaccine will not attack your organ system, because the vaccine raises a specific response against the spike. But the coronavirus, has its spike, and that spike binds to ACE2. ACE2 is expressed in parts of the brain, your intestine, your lung, your kidney, your heart, many organ system, because it's an important angiotensin convertase system that regulates blood pressure and tissue damage and tissue repair. All of that regulation is done by the ACE2 receptor system. So, once those systems are affected, it throws blood pressure off, it throws homeostasis off, it throws tissue repair off, and so you succumb to all different kinds of pathology.
Okay, thank you. Nearing the end of the questions we have here, this one says, how long can the virus live outside of a living cell?
I don't know the answer to that. In the beginning of the pandemic, remember, we were spraying down everything. And then it proved that that wasn't absolutely necessary. There are some studies out there on that, how long it can live. So I'm not going to throw a number out there of couple of hours, 2 hours. I'm not going to throw a number out there. The bug is very susceptible to UV rays. So this is why outside, we talk about less need for, social measures, protection measures outside, because there's a lot of UV light and we're in the sunny time right now. So the UV rays are really high. and you know your droplets from your mouth will not you know go as far outside as when you're inside. So it does have a survival time outside. I can't nail that down right now, but they're highly susceptible to UV rays. So once they are on a surface, you know, they will be hit, and you know you do get some UV rays also from your internal lights, albeit not a lot. You know, in countries like, you know, the sunny Caribbean and Africa, you know, outside a lot, UV rays are destroying a lot of these bugs, but it can live on surfaces. And in these temperate climates, in the winter time, we are concerned about the winter. We spend a lot of times inside. We have shorter days, longer nights, and viruses just love the winter time. This is when we get spikes in the RSV infections and influenza infections. This is when we really see those you know, spikes. But I could look that up and share with you, and you could share with that person if they are interested to learn the time.
Okay, very good. I think this one is the last one I have, unless one comes in. How did the Delta strain get a chance to develop in Israel if so many were vaccinated? You mentioned that vaccination will help against variants.
Yes. So the Delta variant started in India, but as we know, we're in an era where airplanes fly and go everywhere every day. You know, so mass transit is you know, how these bugs are getting around. So as I mentioned, when the coronavirus was detected in 2019 in China, the Chinese sequenced that virus and shared that sequence around the planet to all you know, healthcare bodies around the world. And then these healthcare bodies, you know, scientific community, pharma started to figure out how do we make a vaccine to this. So they used that original strain of that original virus to make, you know, the vaccine. Delta is since so removed from what that original strain was. As a result, vaccines were not as effective against the variant Delta because it has changed. And those changes allows the Delta virus now to gain new skills. So if you're still watching this screen here, you will see that spike engaging the ACE2 receptor. And all these little numbers that you see here, that E480, 484Q, its meaning a change in an amino acids. You see this L5 to R, a changes in another amino acid. So that original Wuhan strain has changed to this new guy, which carries different amino acids in its spike protein. As a result, okay, the vaccine that was developed to neutralize the Wuhan strain is less effective against the Delta strain. And so you have these breakthrough infections, all right? So now the conversation is, how are we going to protect ourselves from, say, Delta Plus or a new emerging variant? It's a really good question. But here's what we have right now. We have a vaccine that is able to prevent worse hospitalization and death, and it's working. Let us try to get the population vaccinated so we achieve herd immunity and corner this bug so it cannot really you know, mutate and more and wreak havoc. It can. It absolutely can. And that will not be good for us. But the more of us are vaccinated, because even though folks are being infected, we do see that the data is pointing towards, and if I could jump to that, the data is pointing towards that vaccinated individual, the cases are lower. So lower cases in vaccinated individuals give the virus less capacity to mutate because it's getting into less people, and we may be able to turn this corner on this thing. But the possibility exists that mutation can arise and we can have another crazy strain popping up. But we just need to kind of corner this thing. You know, you're vaccinated, I'm vaccinated, all 5 people in my house vaccinated, you know what I mean? So this bug runs out of people to infect. What is this going to do? It's going to die out. All right. Now it can be one of those monster thing that, you know, you see on TV that now becomes, you know, even more crazy. But, you know, therapeutics are coming along. All right. So we see that Merck has now made an antiviral, and those are oral tablets now that uses a different biology. All right. So we talk about they are going after, you know, the replication mechanism of the coronavirus and being able to shut it down. So these drugs now are just analogs, you know. So once the virus is replicating, then we are, you know, it uses these viral this nucleic acid analogs, and it incorporates them instead of the real thing, and it dies. So there are other treatment options coming down the pike to help us.
Thank you so very much, sir. We advertised we'd go for 90 minutes, and we have gone for 2 hours and 27 minutes thereabout, and people are still here, people are still engaged. This has been fascinating. Maybe we'll have to consider doing another one of these, but we have learned a lot. Thank you, and we'll talk later off screen. Over to you, Chris.
Well, thank you, Doc. And thank you, Dr. Taylor. With the care and the compassion of Mr. Rogers, with all these great data, and you place it in such a visually accessible means, you've taken us on a tour of all the complexities of this virus. We've certainly been schooled this evening. So thank you so much for that, sir. We know about the history of, you know, yeah, we can get a degree from all of what we've had here tonight. We know what the history of drugs are. We put it in context with other immunities issues that we've had in the past, and with the you've looked at vaccines straight up. I thank you for your transparency and your personalization. You talk about your 14-year-old and your 17-year-old, your entire household. So you're not just talking, you're actually practicing and being such a good model of example. So thank you so much for that. Thank you for what it means to deal with this complexity, even around the political issues that are involved, and give us a very hard, transparent response to it. And so we can't have anything but that. So now the issue is upon us. There are 2 things that we're dealing with here. We clearly have been educated in these last 2.5 hours as to no one can walk away from this engagement said their questions haven't been answered. The issue is, will we put aside fear and misinformation and have the courage of our convictions to do the right thing? And that's really where you've left us this evening. So I pray that folks would prayerfully consider all the information you've had, your transparency. You're certainly a trusted agent on this, and that we'll make the right thing. Again, the takeaway I have, the correlation between vaccination and the reduction of having different variants coming along. We can't miss that, along with the other data. So our heartfelt thanks for sharing this priceless information, and may we, as a group, walk away from here saying thank you, but also take an action to do it ourselves if we haven't so far, or to share this message with somebody else. Thank you again, Dr. Taylor.
Thank you. I'd like to thank everyone for joining us, and please watch out for the next time that we will have a town hall meeting. Now over to you, Pastor Wright, for your final.
Well. Wow. It's not Pastor Wright.
And then the benediction.
It's not Pastor Wright this evening. It's
okay,
it's his assistant. It's his assistant.
Okay.
Unfortunately, Pastor had to leave, but I'm here. And wow, as Dr. Grace Kelly wrote in chat, this, I must admit, has been the most comprehensive, unbiased, and educational presentation I've heard on COVID-19. Thank you, Dr. Taylor. And I strongly concur. You ever hear in Jamaican parlance where you say you're groans? You are a groans guy. And I love this. You know why? Because you brought it home so simply that no one can leave here saying this, oh, this thing was so highfalutin, I don't understand. So from the bottom of our heart, we thank you, Dr. Taylor, and you will hear from us. You will have to be back with us in the future, and bring along your family. We would like to meet those 16 and 17-year-olds. We love you. We love the youth here. Let me just use this opportunity to thank Brother Chris Daly there, that you don't even recognize that we have children who are best friends. Is that Chris Daly? Or is Chris?
That's Chris. That's Chris Daly.
Okay, Danny, Courtney, and Kim are all together, and you know that. This is Kimberly's mommy. Okay, Chris, this is Kimberly's mommy. All right.
I think my internet is going a little wacky here.
Okay.
Yes, we do.
Yes. Okay, so, and thank you so much for hosting. And last but not least on this is Dr. Melbourne, you are a phenomenal person. With all that you're going through, you still find the time to give back. And we truly appreciate that, especially the last week that has passed into her Earth's history was very challenging for you. And I know that. And we thank you. You would have celebrated your 50th with your beloved. And your reward is in heaven, because the love that you both shared continues. And we love you, Pastor Melbourne, and we love you so much. You know, you're like, you're family. RPT, big up yourself, big up, RPT. A small church as this that we had here, let me tell you something. I walk with the echelons, and this that we have, this seminar, I would call it, this is more a symposium here today. This was fantastic, phenomenal for a church of our size. So we thank everybody involved, and we thank our RPT members who shared and got other folks coming on, so we can answer those questions now because we have got more information. Thank you so much. Pastor asked me to remind everybody about next week. Next week, we're going to have a guest speaker. You know, every week at RPT is just, hey. So it's nothing less. Next week is going to be phenomenal also. And in the evening, we're going to have our breast cancer awareness program with Sister Knight. You know, I'm a survivor, and I'll be here, burns and all, okay? Also, we must remember, as I told you this morning, that October is not just about breast cancer. There are so many other things, but domestic violence sits and resides even in church. Hello. So let us be aware of that. Is Elder Julian here? Elder Julian, are you on? Okay, if not, let us bow our heads for prayer. Great God of heaven, we thank you for this beautiful program. We thank you for thy Sabbath day that we spent so wonderfully in the church. Help us to recognize that church is not the four walls. Church is us. So although church may be closed physically in some places, it has always been open because we are here. Lord, we thank you for these programs that we bring out every week. We thank you for the foresight of Pastor Wright. We thank you for his love and passion for people and to make these programs available. We thank you for a phenomenal leader as Dr. BERTRAM Melbourne. Oh Lord, we you know his heart. You know his heart. You know exactly what he's going through now. We ask that he may be supported on every end, know that everything is finished and he's there. Help him never to feel alone. Help him to know that we love him and he's surrounded by not only us, but by a band of angels. And that soon and very soon he'll be reunited with Sister Cavell. Lord, in a special way, I thank you for RPT. We thank you for the great guests that we have. Dr. Taylor, we ask you, Lord, to be with him and his family. Somebody with this brilliance, he has been gifted by you. May he continue to use this for the advocacy of people and for the well-being of others. Help us as a church to understand that it's not about us, but it is about others and it's about you. So we must not live selfishly. This information that we garnered this evening helps us to be more responsible citizens in this world, recognizing that no man is an island and the chain is only as strong as the weakest link. So thank you, Lord, for all of this that we have so capably put on this afternoon on this simple platform. Thank you, thank you, thank you. And now as we face this untried week, we leave our hands and our lives and everything in your divine hands. May we trust your heart, even when we can't understand. Thank you, Lord, and thank you for the Sabbath day that was so well spent. Amen. All right, thank you, folks. Well, you know, at RPT, we stop streaming right now, and we go to the foyer. Yes, although we're on Zoom, we're going to the foyer now. So as soon as I get all clear from Brother D, Uncle D, or can we go to the foyer?
Recording stopped.
Can anybody check Facebook for me and tell me if we have stopped?
He just said
Yes,
recording.
No, I stopped that. No, that was from my, that was from